Hi guys! In our previous lessons, we examined series and parallel connected circuits. In this lesson, I will explain the working principle of combination, series and parallel circuits. At the end of this lesson, you will learn how to calculate equivalent resistance, current, and voltage in series parallel connected resistors. Let's try to learn from an example without wasting any time. In this circuit consisting of resistors R1, R2, and R3 connected to a 9-volt source, let's try to find the current value through each resistor and the voltage values across the resistors. First of all, the first thing we need to do here is to find the equivalent resistance. Of course, there are different solution methods, but I will do it this way. Here, since the two pins of the 6 kΩ and 3 kΩ resistors are joined, it is easily seen that they are parallel. If we call the equivalent of these two resistors Ra, the sum of the inverses of R2 and R3 resistors will be equal to the inverse of the Ra resistor. Hence, 1 over Ra will be equal to 3 over 6 kΩ. When we multiply the insides and outsides, we find the Ra value as 2 kΩ. Now we can find the total equivalent resistance. The resistance R1 on the left side is connected in series with the Ra value we found. If we call the total equivalent resistance RT, this value will be 3 kΩ from the 1 kΩ plus 2 kΩ operation. We have found the equivalent resistance. Now we can find the mains current, that is, the total current. If we call the mains current I, it will be 3 milliamps from the 9 volts divided by 3 kΩ operation. The mains current also flows through resistor R1. So how do we find the currents through resistors R2 and R3? The most important and difficult part is usually here, but there is nothing to be difficult about. If you remember, in parallel connected resistors, the current was inversely proportional to the resistors. Actually, we can see it easily here. Since the mains current is 3 milliamps, 1 milliamp will flow through 6 kΩ, 2 milliamps will flow through 3 kΩ. So, how do we do this mathematically? If we call the current flowing through resistor R2 I2, this value I times 3 kΩ divided by 6 kΩ plus 3 kΩ. When we do this, we find I2 current as 1 milliamp. Since it is inversely proportional to the resistance value, we put the value of the other resistor in the numerator and the sum of the two resistors in the denominator. Thus, we distributed the current inversely proportional to the resistance values. Similarly, if we call the current through resistor R3 I3, we can find the current through this resistor. The value of I3 will be I times 6 kΩ divided by 6 kΩ plus 3 kΩ. When we do this operation, we find the current I3 as 2 milliamps. If the three resistors were connected in parallel, we could solve the problem in the same way. Again, we can distribute them in inverse proportion so that a small current flows through the larger resistor and a large current flows through the smaller resistor. Now that we have found the currents flowing through the resistors, let's find the voltages across the resistors. According to Ohm's law, we can easily find the voltage value by multiplying the resistance values by the current flowing through that resistor. The voltage across resistor R1 will be I times R1, so 3 milliamps times 1 kΩ is 3 volts. The voltage across resistor R2 will be I2 times R2, so 1 milliamp times 6 kΩ would be 6 volts. The voltage across resistor R3 will be I3 times R3, so 2 milliamps times 3 kΩ would be 6 volts. I want you to notice that the voltages across resistors R2 and R3 are both 6 volts. In parallel connected resistors, the voltage values must be the same. If we didn't find it like this, we would have made a mistake. In this way, we can also check the correctness of what we have done. Another point is that the sum of the voltage value of the resistors connected in parallel and the voltage of the resistor R1 connected in series with them is 9 volts. So it was equal to the source voltage. If we had not found a value equal to the source voltage, we would have made a mistake. For a better understanding, let's make another example similar to the example we made. Let's add another R4 resistor in series with a value of 5 kiloohms to this circuit and make the source voltage 12 volts. In this circuit, let's find the current flowing through each resistor and the voltage values on the resistors. First, let's find the total equivalent resistance of this circuit. We have already found the equivalent of 3 kiloohms and 6 kiloohms resistors connected in parallel as 2 kiloohms. We also called this RA. Since the newly connected resistor R4 is also connected in series, we can find the equivalent resistance by adding them all together. The equivalent resistance will be 8 kiloohms from the sum of 1 kiloohm plus 2 kiloohms plus 5 kiloohms. We have found the equivalent resistance. Now we can find the mains current, that is, the total current. If we call the mains current I, it will be 1.5 milliamps from the 12 volts divided by 8 kiloohms operation. The mains current also flows through resistor R1. So, how do we find the currents through resistors R2 and R3? If the mains current is 1.5 milliamps, 0.5 milliamps will flow through 6 kiloohms. If it is 1 milliamp, it will flow through 3 kiloohms. So how do we do this mathematically? If we call the current flowing through the R2 resistor I2, this value becomes I times 3 kiloohms over 9 kiloohms. When we do this operation, we find 0.5 milliamps. Similarly, if we call the current through resistor R3 as I3, we can find the current through this resistor. The value of I3 will be I times 6 kiloohms divided by 9 kiloohms. When we do this operation, we find it as 1 milliamp. Since I2 and I3 currents combine again to form the mains current, I mains current also flows through resistor R4. In other words, the same current flows through R1 and R4 resistors. Now that we have found the currents flowing through the resistors, we can find the voltages across the resistors. The voltage across resistor R1 will be I times R1. So 1.5 milliamps times 1 kiloohm is 1.5 volts. The voltage across resistor R2 will be I2 times R2. So 0.5 milliamps times 6 kiloohms is 3 volts. The voltage across resistor R3 will be I3 times R3. So from 1 milliamp times 3 kiloohms, it will also be 3 volts. Finally, the voltage across resistor R4 will be I times R4. So 1.5 milliamps times 5 kiloohms would be 7.5 volts. We have seen that the voltages of the resistors connected in parallel are the same. We also saw that the sum of the voltages of all the resistors in the circuit, that is, 1.5 volts plus 3 volts plus 7.5 volts, is equal to the source voltage of 12 volts. The working principle of series parallel combination connected circuits is basically like this. You can find a solution in this way while making an example you encounter. I hope this lesson was useful and you liked it. Hope to see you in the next lesson. Goodbye!